Hi everyone and welcome to English Digest. I'm Pat.
And I'm Kat.
And we've got our Newswatch article for this week, and I guess they're both, in one way or another, about codes.
Yeah, you could say that. They're kind of about cracking codes.
Yeah, the first of our two stories is about the kind of secret codes you might think of in spy movies, but of course they do happen in real life, and we've got a story related to a famous World War II example. The second one's a completely different kind of code.
Yeah, I would say it's, the code that makes up our existence. Because we are basically made out of little tiny parts of DNA.
Yep.
So it's about cracking the code of DNA.
Yeah, lots of G's and C's and T's and A's.
Yeah, that's the ones.
Yeah, and how they all pair up in their combinations and encode messages like print this protein.
Yeah, or give the person this, this gene.
Yeah. Pretty much, yep. Okay, so let's read through these two stories and find out what this whole code set or these all these different things to do with codes is all about. Facebook donates $1.3 million to famed code-breaking museum. Facebook has donated $1.3 million to the museum at Bletchley Park, the UK's once top-secret centre for World War II codebreakers. Due to the pandemic, the museum temporarily closed its doors last year and couldn't reopen at full capacity, consequently losing 95% of its typical income before it received the social media giant's donation. The famous site is where thousands of codebreakers worked to crack German communications during the war. It's also where Alan Turing developed the first computer that could decrypt these messages on an industrial scale, contributing to the Allied victory. The museum welcomed guests for decades before COVID-related losses forced it to cut spending and furlough 85% of its staff. However, with Facebook's offer, a number of these jobs could be restored and there was less need for severe budget cuts to exhibitions and educational events. Speaking about the donation, Facebook's Vice President of Northern Europe, Steve Hatch, commented, "The historic achievements of Alan Turing and the Bletchley team have benefited all of us greatly, and we're thrilled to help preserve this spiritual home of modern computing."
Female scientists earn Nobel Prize in Chemistry for gene editing tool. In a historic first for the scientific community, the Nobel Prize in Chemistry has been awarded to 2 female scientists without any male collaborators. U.S. scientist Jennifer Doudna and French professor Emmanuel Charpentier were honored with this distinction for developing CRISPR-Cas9, known as genetic scissors, which can make precise edits to DNA in living cells. Modifying genetic material has long existed as a way to research different gene functions and their impacts on how diseases progress. However, making these edits was not only time-consuming, but also at times impossible, until Doudna and Charpentier introduced their gene editing tool. Now, it is easy for scientists to make specific changes to DNA structures in just a few weeks. By allowing the code of life to be rewritten, this innovation brings the potential to produce new medical treatments or even cures for some genetic conditions, such as blindness. To that end, the scissors are not only transforming biological sciences, but also benefiting humankind in a revolutionary way.
All right, let's take a look at the title of the first of our 2 news pieces. Facebook donates $1.3 million to famed code-breaking museum. So let's take a look at the word donates first. To donate to to someone or something is to give something to that person or that thing, maybe a group or an organization, and you don't expect anything back. It could be money, but you could also donate food, you could donate clothes, you could donate anything. You're just giving somebody or something whatever it is, and you don't expect to get it back.
Exactly.
You feel like, I want to make a contribution, I want to help out this person or group or whatever, and so I'm going to give them this thing, and I don't expect repayment.
Yeah, exactly.
The noun form is, of course, donation, so you can say make a donation or just donate.
Yeah, so Facebook, as we all know, a very, very big social media site, probably the biggest, donated $1.3 million US. So in other words, they gave this money to Bletchley Park without expecting anything back. And we are saying that this is a famed code-breaking museum. So we have this word famed, which basically you could take to mean famous. Yeah. And it's just another way to say famous.
Yes, well known.
Yeah. And when you say code breaking, we already talked about code. Of course, code is when you have a set of symbols or something else that stands in for a different language. Like it's something that is hard for normal people to understand. But if you are a code breaker, then you are a person who kind of figures out the code. It's almost like figuring out a math problem. But you are trying to find out and understand what that code is saying. So code breaking is the process of figuring out a code.
Yeah, you learn all the kind of secrets, like, okay, this means this means this.
Yeah,
You've
like
got the
A
system.
means Z, Z means, I don't know.
A, I suppose. Or a simple one where it's like, well, 1 is A, 2 is B. Those are very simple codes.
Exactly.
The ones used in the war were more difficult to break. So to crack or to break the code, you needed a lot of skill and, as we'll find out, computers.
Yeah, exactly.
So we learned that Facebook has donated this amount of money, this $1.3 million US, to the museum at Bletchley Park. And this museum in Bletchley Park was once, it says it's the UK's once top secret centre for World War II code breakers. A code breaker is just a person who works on breaking code.
I guess this was the British code breakers who were working on the German front.
Exactly, yeah. They would get the German messages either from spies or from their telegraphs, and they would try to break the code and work out what orders the Germans were giving. Where were their planes going to be? Where were their armies moving to? What was happening? That kind of thing.
Yeah, and these codes could give them very crucial information.
Right.
I think one of them allowed them to sink a massive ship, right?
I'm sure that there's all sorts of things like that. Yeah, figuring it out. Maybe it's like the coordinates for where the mines are and you're trying to get through a German territory, or where are those armies going to move to next, or things like that.
Right.
And you use that information. If you know it and the other team doesn't know you know it, you win because you can get all their plans.
Yeah, exactly. And so the people who do this, who do code breaking, are code breakers. Exactly. And so what is going on with Bletchley Park? Why did they have to donate this, or why did they choose to donate this $1.3 million US to Bletchley Park Museum? Due to the pandemic, the museum temporarily closed its doors last year and couldn't reopen at full capacity. And consequently, as a consequence of this happening, losing 95% of its typical income before it received the social media giant's donation. So basically, because of the pandemic, like many other museums, Bletchley Park had to close in 2020, and all but 5% of its income was gone because they couldn't take tickets, they couldn't accept visitors. When you're not making
money.
When you're not making money, you struggle to stay open.
Exactly. So it needed some help. Obviously, there wasn't enough money coming in from British government sources, which is kind of surprising, really. You'd hope that they would put in some money to keep these kinds of places alive, but
or maybe they didn't have the money.
Yes, that's true. It goes to the NHS, but Facebook steps in. So we learn a bit more about Bletchley Park here. The famous site is where thousands of codebreakers worked to crack German communications during the war. I kind of mentioned this earlier. To crack a code is to basically understand its secrets. You solve the problem. So that means once you've got the key to the code, any message in code, you can now read it without any extra problem.
Right. So once they've cracked the communications, once they've cracked the code, then they can understand and make their next move. And there's another important particular person who worked at Bletchley Park during that time. It says it's also where Alan Turing developed the first computer that could decrypt these messages on an industrial scale, contributing to the Allied victory. So Alan Turing, if you've heard of him, you probably know him as the father of modern computing. He is an extremely important figure who not only helped to make the computers that could help to win the war, but also he created something called the Turing test, which is what we now use to monitor whether robots can be as smart as humans.
Cool.
And no robot has cracked it yet, as far as I know. So, yeah, no robot has passed the Turing test, but that's from Alan Turing. And he developed a computer that could decrypt these messages. Now, to decrypt something, if something is encrypted, that means it is put into a code so that it's safeguarded and hard to crack. Like a modern example would be your line messages between you and another person. They are encrypted so that hackers can't get into them and get your private information. And so to decrypt is to get through the encryption and to find a way to crack it. So basically, decrypt is another word for crack, you could say.
Yes.
Yeah.
And this contributed to the Allied victory. The Allies was the name given to the UK, France, the US, and a bunch of other nations who were on one side during World War II. Okay, so we know that the museum welcomed guests for decades before COVID-related losses forced it to cut spending and furlough 85% of its staff.
Ouch.
So this is another one of those difficult words in English where you've got O-U-G-H. It kind of sounds like O. Yeah, it's like though and thorough and all of those others. To furlough staff means to lay them off. It doesn't mean they're fired. It doesn't mean they can't ever come back. It's just they're not going to work there and they're not going to get paid right now. You just can't afford to.
But it's a temporary one.
Yeah, furloughing is generally temporary while a situation is bad or possibly even until someone's contract runs out. And it's done when there's a problem going on with the business. The problem isn't with the workers, it's with the overall business. They just can't afford to, or maybe the job that they were working has just, they don't do that job anymore. It's gone.
Yeah.
So these people are basically out of work, not going to get paid, although hopefully when the business improves, they get to come back.
Yeah, exactly. I remember there's so many people who've had to be furloughed during the pandemic. And during government shutdowns in the U.S., a lot of government workers get temporarily furloughed. They stop being paid, and then they're said to get their payment when the government starts running again, but who knows how long that takes, of course. So, yeah, the staff have been at least temporarily laid off, maybe permanently. They weren't sure what the situation was going to be.
Yeah, and we still aren't really, COVID being what it is.
Yeah. However, here's some good news. With Facebook's offer, a number of these jobs could be restored, and there was less need for severe budget cuts to exhibitions and educational events. So it means that a lot of its staff got to come back. They get to be paid again. It's really good.
Yep, and a lot of things stay open. Things that they might have otherwise closed down permanently, maybe sold off to somewhere else.
Yeah.
The workshops for educating people on either history or code cracking get to kind of stay open when the museum can open again.
Yeah, exactly.
So speaking about this donation, Facebook's Vice President of Northern Europe, Steve Hatch, had something to say. Now, he's a vice president. It's basically the president's number two, the second in command. You have a president, like Joe Biden, and you have the vice president, Kamala Harris. So there you go. She's the second person behind Joe Biden. If something happens to him, then Kamala Harris will kind of take over his role in whether it's for a short time or permanently. So a lot of these companies will have vice presidents of something or vice president overall, and they will basically be the ones to step in and take over when the president is busy or sick or something else.
And with a big company like Facebook, this person's the vice president of Northern Europe, so I presume there's other vice presidents for other regions.
Yes, Asia, India, America,
so there could be
and so on.
There could be a number of vice presidents presidents or vice executives, something like that. They just need to be kind of the second in command for that particular thing. Yeah, so what did he say? Well, he said, the historic achievements of Alan Turing and the Bletchley team have benefited all of us greatly, and we're thrilled to help preserve this spiritual home of modern computing. So basically he's saying we're really, really happy that, we're able to stay open because this is a very important place historically. It's a very important place, as far as these people who achieved a great deal during the war and afterward. And we're thrilled. If you're thrilled, it means you're just so happy. You're so, I guess you'd say, Britain, chuffed.
Yes.
And very pleased about something. Like if you're thrilled, you're beyond pleased. You're extremely pleased, I guess you could say. Like, I'm thrilled to be working at AMC.
Yeah.
Let's say that. Yeah.
You're kind of communicating that it's an honor, it's something that everybody likes, that kind of thing.
It's a very good thing.
Yes, and we're calling it, or he called it, the spiritual home of modern computing. So the spiritual home is basically the home of its spirit. It's kind of where a lot of the ideas, a lot of the first kind of thoughts and plans were put in place were taking place, even though some of the actual work and building of modern computers maybe happened elsewhere. It's basically this idea Turing comes up with a machine that can do something on an industrial scale. So it can do hundreds or thousands of things at once.
Right.
So that's where this idea was born, where Turing developed this computer. And so all computers follow those same kind of processes. Kat mentioned the Turing test. So it's kind of the place where the ideas, the spirit, the heart came from, even if a lot of the physical stuff happened elsewhere. That's what we mean by spiritual in this case.
Yeah, so you can probably go to Bletchley Park to learn a great deal about computing and about code breaking. Sounds like an interesting place to visit.
Indeed. And computing, of course, is just the kind of business, the action, anything to do with computers.
Yes. What computers do, they compute. Yeah.
All right, well, that is the end of our first news story. We've got another one coming up in just a moment, but right now we'll take a short break.
All right, welcome back. We are moving on to our second part of the Newswatch article where we are talking about female scientists earn a Nobel Prize in chemistry for gene editing tool. So yeah, we have basically the title summarizes it pretty well. That there are two female scientists who won by themselves a prize that has never been won by two female scientists before. In fact, maybe not even by one.
Yeah, that's kind of the real key to what sets this story apart. I mean, every year someone wins a Nobel Prize in chemistry for doing something.
Yeah.
But this is, as we see in the article, in a historic first for the scientific community. The Nobel Prize in chemistry has been awarded to two female scientists without any male collaborators. So,
well
of course,
done.
this was announced back in sort of October, November last year. They've had the ceremony and all that, but it was a first. It was the first time any female scientists have won without any male help. That's what we mean by collaborators. If you are a collaborator, you are somebody who works together on something with another person.
Collaboration being the act of collaborating or being a collaborator. All right, so who are these two women who have won this Nobel Prize? It says U.S. scientist Jennifer Doudna and French professor Emmanuel Charpentier were honored with this distinction for developing CRISPR-Cas9, known as genetic scissors, which can make precise edits to DNA in living cells. Now, the interesting thing is we've already done an article previously on CRISPR-Cas9, or something related to it. There was a Chinese scientist who edited some genes in a pair of twin baby girls.
Right.
Yes, and he used this technology that they are being honored for. So that's a different story, but these two women, Jennifer Doudna and Emmanuel Charpentier, were the ones who developed it. And so they have something that's already quite famous, and it's being hailed as something very important. So they were honored with the distinction of a Nobel Prize in chemistry. So there's a number of meanings for distinction, but this one is kind of like an honor. It's an award that you are you're honored, you are humbled to receive. You would usually go up to the stage and say, I'm honored to earn this distinction, this very high-ranking award that is it's a big thing in your life, you could say.
Exactly, yeah. A distinction can also mean something that sets you apart from something else, makes it easy to tell the difference. And that kind of works here because a distinction would be a very high honor. A lot of people get honored for something, but these two have the distinction of a Nobel Prize. It's pretty much one of the top prizes in chemistry. So therefore, winning it is, it's a mark of distinction. It's a mark that you have done something, created something, achieved something that is higher than what a lot of other people have done this year in this field.
Yeah, so what is the distinction for? It's CRISPR-Cas9 or Cas9, known as genetic scissors.
Ooh.
Yes, so something that is genetic has to do with your genes, with your DNA. So if you're thinking about scissors that are genetic scissors, these can basically cut your genes apart. They can kind of do microsurgery on like a little string of DNA, which is really interesting, that you can just basically take it apart and put it back together in a different way, like a puzzle.
Yeah. I was studying this stuff back when I was a biochemistry student back in 99, 2000, early 2000s. And yeah, this technology hadn't been invented then. It was talked about as a sort of, wouldn't it be great if we could?
And now we can.
Yeah, because back then, most of the efforts were trying to identify which sections of DNA did what. Like, what did this string of DNA, what protein does that make? What does the protein do in the body? We were still figuring out the whole kind of human genome at that point. It hadn't quite been done.
I remember when they said we've mapped the human genome, and how big a deal that was.
Yeah, and figured out which particular genes go with which particular result that we can see, that kind of thing. So the idea that you could cut a gene out or cut one in two was the sort of thing where it was like, it'll be great if we can do this, or maybe one day they'll do this. So kind of 20 odd years later, here we are.
Yes, exactly.
Okay, so there were other ways to do it, and that's why this was kind of talked about. It was something you could work out how to do, but it was clumsy, it took ages, it wasn't as accurate as just going, we'll make a cut here and a cut there. So that's why we say in the next paragraph, modifying genetic material has long existed as a way to research different gene functions and their impacts on how diseases progress. So to modify something means to change something. And that's what people could do back when I was still a student. They could work on different ways like, we can put this gene in this. Well, we used fruit flies a lot for experiments.
Oh.
Put this gene in this fruit fly and see what happens with it. Does it do this? Does it do this?
I guess that makes sense because they have very short lives.
And
so you see the results very quickly.
Yeah, and also very short, simple DNA structures that they already had completely encoded or broken the code for.
Makes sense.
So they knew exactly what was what. But it was very difficult to do that kind of experiment. It took a long time. You had to breed these fruit flies. It wasn't as easy and sort of simple as these scissors have made it appear, as we say in our next sentence.
Yeah, so it says, however, making these edits was not only time-consuming, but also at times impossible, until Doudna and Charpentier introduced their gene editing tool. So we have basically a grammar point, which is until. So until means that A was true up to a certain time point, and then B was true. A was true until B was true.
Yeah, it marks a change when something happens and talks about what happened before then and then up to and afterwards. And until is the point of change.
Yeah, exactly. So it was time-consuming, probably took months.
Oh, yeah.
And then sometimes you couldn't do it at all.
Right. You just couldn't get the right gene or it was too difficult. Because you had to use certain types of enzymes, which are things that break down larger structures.
Yeah.
And so you could never get it exactly right. It was just very difficult and could be impossible if you weren't quite sure where to cut.
Yeah.
But now, as the article says, it is easy for scientists to make specific changes to DNA structures in just a few weeks. They can go, all right, cut here, mix put them back together again, just like you were cutting film on a movie in the days when they did that before digital technology. So these gene editing scissors are kind of like digital technology for DNA, if you think of how films used to be cut bits of tape together and stuff like that.
Yeah, exactly.
All right, so great, very useful.
Yeah, and so what can we do with this now? By allowing the code of life to be rewritten, there's that code, this innovation brings the potential to produce new medical treatments or even cures for some genetic conditions, such as blindness. Yeah, so I think basically you couldn't really modify the DNA of a person who's already fully grown. Right?
No, well, not because you'd be, which cells are you going into to change it?
Right,
it
right.
already
There's
happened.
too many. But you could do it in embryos, maybe small fetuses, eggs.
Stem cells, some of the early stuff, yes.
Yeah, exactly. So you could prevent genetic problems from happening if you can see that they might happen. So new medical treatments might be, maybe treating cancer?
Yeah, people will have genes that make them more likely to develop certain things. People will have genes in them for long-standing genetic diseases like heart problems and things like that. So if you know that you have a certain problem and you want to make sure you don't pass it to your children, there may be a way with these scissors to either treat it so at least it's not as bad or even cure it. So if you were born blind, if it's a genetic blindness, you can maybe make sure that your children aren't born blind in the same way.
Right. And eventually they may be able to kind of cure or treat, people by targeting specific cells. But
exactly.
We don't know yet.
Yeah, but to that end, or with this goal in mind, the scissors are not only transforming biological sciences, but also benefiting humankind in a revolutionary way. So as I say, to that end means to achieve that goal or in looking at that goal. And biological sciences is the life sciences. It's anything to do with life rather than physical sciences like maths or traveling to outer space. This is the science of life.
Yeah, so bio be life and logy is study, the study of life. That's biology. So we are looking at that, and it's also benefiting humankind in a revolutionary way. So something that is revolutionary or causes a revolution, it means that it creates like a dramatic change, a very big change that is usually a positive one, and makes it so that things are going to be very, very different and probably it'll totally change life in the future.
Yeah, it just gives...
It'll totally change medicine.
Exactly. We'll change the way we look at certain diseases and certain things. Things that were a problem won't be. We'll just go, great, that time is gone. We're in a new time now. Okay, so sounds very positive.
Yeah,
and
very hopeful.
Good to have a couple of news positive stories in our magazine.
Yeah, exactly. And congratulations to the 2 Nobel Prize winners. Very proud of them.
Yep, good on you.
All right.
All right, that's all the time we have for today. Thanks for listening, everyone. For English Digest, I'm Pat.
And I'm Kat.
And we'll talk to you soon. Bye-bye.
Bye.